Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of proportional and non-proportional graphs. This is standard 8.5F in the great state of Texas, and we are using item number 13 of the 2024 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. All right, so we have got one statement here. We need to find a relationship that best describes a proportional relationship. And we have two equations and two graphs that we need to look at. All right, so what is a proportional relationship? And if you know what it means, this is probably going to be a pretty simple question to look at. But let's pretend we don't know what this means, proportional relationship. Well, what I want us to notice here is we've got a graph B and D, all right? So we can see that B, right, has a slope that increases, right? And it goes through the origin there. What we notice about D, it's a vertical line, right? So it's an undefined slope because it goes up and down continually, but it never moves left and right, and it's over there at -4. So what do we know about A and C? What we can actually do here, if we want, is we can graph these real quick, right? So let's just, you know what? Let's graph on Desmos. That'd be a little bit quicker, right? Let's graph these, and I want you to see what we're going to notice here. So we're going to pull this up, and we're just going to plug this in. Y equals, let's make this 3/4 x minus 6. Okay, so we notice we've got a line there. It's rising again, and it crosses the y-intercept at, or the y-axis at -6, which makes sense, right? Because that's going to be our y-intercept, right? So we could draw something like that if we really wanted to. Over here, right? We can draw a little graph. We could do something like this, and we can say, all right, it's going to be a positive, and it's going to kind of move something like this, and we'll call this, -6. And it looks like it crosses the x-axis at 10. All right, so that's going to be our representation of A. Let's see what we have here for B. Y equals x plus 4. All right, so it's also rising, and it crosses the x-axis at -4, the y-axis at +4. All right, so we could do the same type thing here. Let's draw another little graph. We'll do it down here. And it's going to kind of rise like this. It looks like this was -4. This was +4. All right, so we have got some representations, right? And this is going to be my C, right? If we can move those in there. So what we should notice here, if we're looking for a proportional relationship, once again, if you know what this word means, you can answer this question in about 5 seconds. But we're looking for one answer that's different than the others. And a lot of times when we're graphing, the big question is what happens at the origin? Do any of these move through the origin, right? And so when we're looking at A, there's the origin. The graph does not move through the origin. And if we think about our slope-intercept form, y equals mx plus b, this b is literally your y-intercept. This says -6. That's why it crosses the y-axis at -6. We don't have an equation here for b. We could figure one out if we wanted to use the different points to find the slope, but we notice it does go through the origin right there. C does not go through the origin. It crosses the y-axis at 4 because, right, it's got a y-intercept of +4. And D doesn't go through the origin. So proportional means, does it go through the origin? The only one that does is our answer B.